Capturing signals that contain different pulse widths can be a challenge. The timeout trigger mode can help. Let's perform an experiment and take a closer look. In this example, we output an arbitrary wave from a Rigol DG4000 arbitrary waveform generator with a voltage peak-to-peak of 5 volts and a period of 40 milliseconds. Now we configure the waveform to have 3 pulses in every period. 2 of them have a 5 millisecond pulse width, and the third has a 10 millisecond pulse width. Now we connect the signal to channel 1 of a DS2000 oscilloscope. Press Auto. The trigger is not stable because there are 3 trigger events in every period. Using single mode, we can see that the trigger point is not fixed. Now let's try the timeout trigger. Set the trigger mode to timeout trigger and the source to channel 1. Now press the slope button to set the edge type to rising. Hit the time button to set the timeout value. In order to get a stable trigger here, we need to set the time between 7 milliseconds and 10 milliseconds. Now the trigger point is fixed. Note in this example, if the timeout is shorter than 5 milliseconds or longer than 10 milliseconds, the trigger will not be stable because there are no pulses shorter than 5 milliseconds, nor are there any longer than 10 milliseconds in the waveform. Here are some key points for timeout triggering. I'm going to adjust the vertical scale and time base to match the signal of interest. Choose the timeout trigger, set the proper slope, and set the proper timeout interval. Thank you.